Okay, so on to uncertainties. Right now we do have these cross-shaped markers, but they currently do not represent the uncertainties. What we're actually going to do is format this and change the marker type to none. Now obviously they disappear because there's no marker, but don't worry, the data points are still there, they just can't be seen because there's no marker. Now we're going to represent this with error bars instead. Now if you just go to error bars and select the one with standard error, you get something like this, and you can just change these based on a fixed value usually. Let's say my scale is uncertain by 20 grams, and I also have a really bad ruler that's uncertain by about 2 centimeters. So this is going to be my uncertainty for the data points. Now the next thing we want to do is add the lines of worst fit to show the extremes. So what we're going to go do is go to design and edit the data, to open up this Excel sheet again. And what we're actually going to do is get this data and move it down 2 blocks, so there's 2 empty ones on top, and we're also going to extend this down 2 more, so we have 2 lines on top and 2 lines underneath, and we'll add 2 more columns as well. We'll call it worst 1 and worst 2. Now just for clarity, I'll highlight this in yellow because this is all of our data points. Alright, everything around it, all of this space, all of this space, and all of this space, all of this is not our actual data points. So these have already been selected and these are our data points, and we can work around it as much as we like. So now we need to do the lines of worst fit. Now let's have a closer look at this. If we want the extreme from this corner, I can say this is at 70 on the x-axis and this is at 2 on the y-axis. So what we're going to do is go on the x-axis, we'll put a 70 here and we'll put a 2 here, and that will be our first point. So we'll have a point here, and the other point we want to draw up to is this point here. So this is going to be at what, 470, and up here it'll be at 44, I think. So this will be what, 470 and 44 down here. Now again, remember, this doesn't change any of our data points, this is just for our worst fit line. So now what do we do with this line? We go back to here and we can add a trend line again, but since we have more columns now, once we add a trend line we can pick which series. So we'll go for the worst 1, and this is the trend line that we get, and as you can see it barely nicks the corner of both of them because I did it so perfectly, I know. And we'll just forecast this forwards 50 as well, and just to make it clear that this is our worst fit line, we're going to go to change the type of line and make it a dotted line. So this will be our first line of worst fit, and it just barely goes through the corner, it goes through every single point and every single uncertainty box, and that is our first line of worst fit. So that's what we needed that for. And yeah, this space is just going to be empty because we don't need anything else in there. So we'll look at the other extreme again. This would be at 30 and it will reach up to 6. So 30 across there, and this will be 6. And then the most extreme in this corner, this looks like 520, and this looks to be about 41. So we'll have 520 here and we'll make it go up to 41. Now remember, this actually I think it can be on the same, actually no, it can't. Remember, this has to be on a new line because it has to be paired with a different x value. And of course if we leave everything else inside blank, then we should have no problems. So we'll go back to this graph now, and we'll add another trend line for worst 2, and as you can see it just barely touches the corner because I cheated with my uncertainties and made them really easy. But yeah, life probably won't be this easy for you, unfortunately. And we'll also make this a dashed line, keep it with the same format, and there we have our lines of worst fit. So these are our 2 lines of worst fit. We have the line of best fit in the middle, and this is the end result of that. But now I know that this looks really good, and I honestly think it does too, but unfortunately life is not that easy, and physics in particular is not that easy. Now what if we have a situation where we want the uncertainty to change for each point? If we just go and click on the axes, we can have a fixed value for all the points, but it doesn't look like in here there is any way to have a different uncertainty for each point. And if we have the square of your value, if you square your values and graph them, then obviously the uncertainty is going to change. So in this case, what you're going to do is edit the data here. We have our x and y, and we'll make 2 new columns again. This one will be called uncert1, and I'll call this one uncert2. You don't really have to label them if you don't want to, but I'm doing it for clarity here. And here's my extension squared in the table, and this is my uncertainty for each of them. So this will be 8, 10, 20, 30, 40, 50, 60, 70, 80, and 90. And in the uncertainty 2, we'll just have the exact same thing. You'll understand why later. Okay, so for this part, now we want a different uncertainty for each point. We can go to custom and specify the value, right? So this is the positive error value, and this is the negative error value. So we'll click that, and then we can select this for the positive side, and okay, and this is the negative side. Okay, this is why we need 2 boxes, because it doesn't let you select the same one. So you close that, and now as you can see, the uncertainty is getting bigger every single point, and that's how it should look when you square your y value. So that's how to get a progressive uncertainty. And we've also looked at the line of best fit, the line of worst fit, and yeah, we've basically covered everything about uncertainties. Let's see, some things you can do with your trend lines. If you just double click them and show the equation, then obviously you do get the equation, and with this you are able to find the gradient and other things if you know how to work with that. So that's cool, but you do need to know how to find the gradient by hand, by yourself, without cheating like this. But other than that, I think I have given you all the tools that you need to make a graph to make your science teacher proud.